Okay everyone, today we're going to look at a thing called small angle approximations, and it's an approximation that we can use when our angle theta is very small for the trig identity, so for sine, cos and tan. But before we do my video, you must watch the video of the proof first. And I've put the link to this on Edmodo, so you have to watch that first, okay? So if you haven't, press pause, go watch that and then come back. Right, so I'm going to assume you've watched the video. So we know our small angle approximations now. And we saw in the video that our sine theta was approximately equal to theta when theta is small. And we can also use the graph to show that. And so the first graph that you can see there is the graph of sine theta between minus pi and pi. And the graph of y equals theta. And you can see for this part here, when the angle is very small, so just when theta is in a very small range around 0, you can see that the two graphs pretty much overlap each other. I'm going to go to the one on the right now, the tan theta, and you can see it's a very similar situation. So again, when theta is very close to 0, we can see the lines of y equals tan theta and the line of y equals theta are practically on top of each other. So that's why sine theta and tan theta always approximate to 0. Now cos theta is a little bit different because obviously, as you can see with the graph in the middle, cos theta between minus pi and pi, okay? And you can see we've approximated it with 1 minus theta squared over 2. And again, in this quite small region, quite close to 0, the graphs more or less overlap each other. So our approximation for cos theta, so the one that's a little bit more complicated, is 1 minus theta squared divided by 2. Now, big question, what do we mean by small? And this is where actually I want you to get your calculators out and have a bit of a play. And for instance, make sure your calculator's in radians, and if you do the sine of 0.1 in your calculator, you will get that the sine of 0.1 is 0.0998. So really the sine of 0.1, if we were to go to 2 decimal places, is 0.1. Okay, and you can do that with sine, cos and tan. If we start getting a bit bigger, let's try the sine of 0.3. Well, the sine of 0.3 then becomes 0.2955. So again, that's still pretty close to 0.3. And if I do the tan of 0.3, I get 0.309. So we're still in a good range at the minute. Now, if I were to go a bit bigger, and let's say I'm going to do the sine of 1, well, the sine of 1 suddenly becomes 0.84. And that is quite a considerable distance. So my rule of thumb is if you're in the low tenths, so maybe up to 3/10, 4/10, you can probably consider that a small angle. If you're getting much bigger than that, then it's not, you can't use these approximations. Okay, but there's no strict rule on this. If you try and Google it, there's no definitive answer to what a small angle is. But a rule of thumb is 3/10, 2/10, possibly 4/10, but don't really be going much bigger than that. Okay, so how are we going to use these small angle approximations? Well, before we do that, I need to show you a step first. And we've got our 3 approximations, sine theta and tan theta are approximately equal to theta, and cos theta is approximately 1 minus theta squared over 2, which is why we use that little squiggly equal sign, because it means approximately equal to. But how do we do things that aren't quite as we've put there? So, what is sine 3 theta? Well, if I look here, you could think of the sine theta equals theta. So what do we think the sine of 3 theta is? Well, the sine of 3 theta is just going to be 3 theta because it's the argument. That's what we call the thing that is acted upon, the argument. And I'll go to the tan one again because these are the easier of the two, sine and tan. So if I know that tan of theta equals theta, then the tan of theta minus pi by 4 is going to be theta minus pi by 4, approximately. So these all should have the little approximately symbols now. Now, when you go to cos 4 theta, you have to be careful, okay? Because again, if I go back to my cos theta equals 1 minus theta squared, well, the argument is in that. It's the theta. So when I do the cos of 4 theta, I've got 1 minus my argument squared. So I've got the 4 theta squared and still divided by 2, okay? So I need to simplify this. Well, I've still got 1 minus. Remember, when you're squaring something outside a bracket, everything in the bracket is squared. So I've got 4 squared and the theta squared. So I've got 16 theta squared divided by 2, which would be 8 theta squared. Okay. Right, just a couple of other ones. Again, sine, we know sine theta equals theta. So this is the argument. So sine of theta divided by 3 is just going to be theta divided by 3. And I'll just show you this last one. We know cos theta is 1 minus theta squared over 2. So it's going to be 1 minus whatever the argument is squared. Oops, that divide shouldn't go all the way across because it's only over the theta squared over 2. So what's that? I've got 1 minus. Well, I'm going to square everything in that bracket. So I've got 4 theta squared over 9 divided by 2. So let's do a little bit on the side. 4 theta squared over 9 divided by 2 is the same as 4 theta squared over 9 times a half. And that would be, cancel those, it's going to be 2 theta squared over 9. Okay, or the other simpler ways of thinking about it is what's a half of 4 theta squared over 9? It's going to be 2 theta squared over 9. So you've got 1 minus 2 theta squared over 9. Okay, so type of questions they're going to ask in the exam are going to be things like this. So when theta is small, find the approximation for sine 2 theta plus tan theta over 2 theta. So I almost always start off by writing my approximations down quickly. So I know sine and tan are approximately equal to theta, and cos theta is approximately equal to 1 minus theta squared over 2. So sine 2 theta is going to approximately be 2 theta. Tan theta is approximately theta divided by my 2 theta. So guess what? I've got 3 theta over 2 theta. So when I cancel it out, it is going to be, sorry, I should put my approximately in equals. So sine 2 theta plus tan theta all over 2 theta is going to be approximately 3 over 2. And again, try it. Put a small angle in. Put a theta of 0.1 in your calculator. And you should get an answer that's really close to a half. Right. Cos is always a slightly more difficult one. And quite often I'll work out what cos 4 theta is on the side before I start. So it's 1 minus 4 theta all squared over 2. So that's going to be 1 minus 8 theta squared. So I've got 1 minus 8 theta squared, take away 1 over theta times, well, sine theta is approximately theta, so sine 2 theta is approximately 2 theta. Right, so 1 take away 1 on the top, so there you go. So I've got minus 8 theta squared on the numerator, and I've got 2 theta squared in the denominator. Theta squareds are going to cancel, so it's going to be approximately equal to minus 4. Again, try it in your calculator. Right, last one. So with this one, change colour. So again, because cos is a little bit more complicated, I will usually do a little bit of work on the side first. So I'll think cos 3 theta is 1 minus 3 theta squared over 2. So that's going to be approximately equal to 1 minus 9 theta squared over 2. And in this case, if you look, you actually want 2 lots of cos 3 theta. So I'm going to do that. 2 lots of cos 3 theta is going to be 2 minus 9 theta squared, because I want to double both of the terms in there. So I've got 1 minus, and I put it in brackets here because you can really trip up on this negative, 2 minus 9 theta squared all over, well, the approximation for tan is theta, so I've got 3 theta minus 1. Right, so let's think about this. 1 minus this bracket. Well, 1 take away 2 is minus 1, but you have to be really careful here because you've got the situation of this double negative, and if we're taking away a negative value, it becomes plus 9 theta squared over 3 theta minus 1. Now, I'm going to write that a nicer way round, and hopefully you will see something when I write this, because another thing that they quite often put in these small angle approximations is they want you to notice the difference of 2 squares, so things will cancel down a little bit more. And we know 9 theta squared minus 1 is, because I'm going to run out of room, so I'm going to have to go to the side rather than underneath, 3 theta plus 1 times 3 theta minus 1, because it's a difference of 2 squares all over 3 theta minus 1. And what you find is they cancel, so we end up with 3 theta plus 1. So our small angle approximation for 1 minus 2 cos 3 theta all over tan 3 theta minus 1 is approximately 3 theta plus 1. Okay? Right, so they can take it one little step further, and they can then get you to solve equations when the angle is small. So the first thing it might be, find the small angle approximation for this, and hence solve the equation this. So do the first part. So again, I just do this out of habit. Sine theta is approximately theta, tan theta is approximately theta, and cos theta is approximately 1 minus theta squared over 2. So my sine 5 theta is going to be approximately 5 theta. My tan 2 theta is going to be approximately 2 theta. And my cos 2 theta is going to be approximately 1 minus 2 theta all squared divided by 2, which is 1 minus 2 theta squared. Okay, so when I put that in, I'm going to get 5 theta plus 2 theta minus, and again remember put this in brackets, 1 minus 2 theta squared. So what's that going to simplify to? It's going to simplify to approximately 7 theta minus 1 plus 2 theta squared. Okay, right, so that's what my trig simplified to. But the second part said, hence solve this. So I know I'm going to use my small angle approximation. So 7 theta minus 1 plus 2 theta squared is equal to 12 theta squared minus 32 theta minus 5. Right, what have I got? I've got a quadratic in theta. Need to make it equal to 0. So I'm going to get 10 theta squared, because I'm going to take 2 theta squared away from both sides, minus 39 theta minus 4. And to be honest, at this point you can just put this in your calculator. So again, use your menu button, find your equation editor, do 2 polynomial, and we've got 10 theta squared minus 39 theta and minus 4, and you'll get your answer of theta equals minus 4, or theta equals plus 4, or theta equals minus 1 over 10. Right, now this is the really important part with this, because you'll lose the last mark or two. We have used a small angle approximation. So that means that this equation here is only valid for small angles. Theta equals 4 is not a small angle. So you have to at that point go, that is not small, so it's not a solution. So my solution is theta equals minus 1/10. That is the only solution that you have. Okay. And the final type of question that they might ask, again, we'll always start off the same. Show that when theta is small, sine 3 theta plus cos 2 theta equals this, and hence state the approximate value of that for small values of theta. So, as always, start off the same way. So, I know sine 3 theta is approximately 3 theta. I know cos 2 theta is approximately 1 minus all of 2 theta squared divided by 2, which becomes 2 theta squared. Okay, I don't like writing that too often because people sometimes start just substituting that argument there. It's not. Remember, it's the fact that it was all of 2 theta squared over 2, which made it 1 minus 2 theta squared. So our small angle approximation is going to be 3 theta plus 1 minus 2 theta squared. So that's going to approximately be equal to 1 plus 3 theta minus 2 theta squared, which was required. Okay, so we've done the proof. Now part B says, hence find what the value is of sine 3 theta plus cos 2 theta when theta is small. So when theta is small, you could say 3 theta and 2 theta squared are negligible because they're small as well. So actually, sine 3 theta plus cos 2 theta is going to be approximately 1 because effectively those two bits cancel out. It's a bit like when you said as theta tends to 0. It's almost asking the same sort of thing. If theta is small, what is that going to be approximately? Well, it's going to be around 1. Okay. Right. So I've got a few questions for you to do. So I'm going to flip my sheet around and show you. As always, have a go at these questions, press pause, and I'll show you solutions when you're finished. Okay, so here we go for the solutions. So for the first one, you should have ended up with 1 minus cos theta all over theta sine 2 theta is approximately equal to 1/4. The next one, theta tan theta over 1 minus cos theta should approximately be equal to 2. And the final one, cos 6 theta minus 1 over sine 3 theta tan theta, hopefully you had was approximately minus 6. And again, test it out. Put a small value into this equation here, and hopefully you should get an answer that is pretty close to minus 6. And if you don't, go check your work. Right, second question then. So, show that the small angle approximation is this. Now, they were nice here because they were giving you a clue to the fact that you actually end up with 4 theta squared minus 1 over 2 theta minus 1. And then you've got to remember to do your difference of 2 squares. Okay. Right, number 3. So, first of all, show that this can be written like this when theta is small. So again, I do my cos 5 theta. So actually, I then write what 32 cos 5 theta is. I do my tan 10 theta. So I did my 203 tan 10 theta. And I substituted it all in, made it equal to 0. And then I divided through by 10, so we got the solution that they required, okay? Because they said, show it can be written this. Now again, you've got to solve that. So just using the quadratic formula, well, really, you're just using your calculator, you end up with theta equals 5 or theta equals 3 over 40. 5 is not small, so it's not a solution. So your answer is 3 over 40. Okay, and the final one, so when theta is small, show that, fairly straightforward. I would imagine you all managed to do that quite easily. Hence solve, that equals 1. So quite simple, because we've just got 3 over 2 theta equals 1. So theta equals 3 over 2. But the thing, it's giving you a clue here and comment on the validity of your result. So it wants you to say something here. And actually, if you think about the value of 3 over 2, it's 1.5. So you can actually say, but this is not small, so it's not a valid result. And that's all it wants you to say. Is it a valid result or is it not? And in this case, it is not a valid result. So when theta equals 3 over 2, sine theta plus 2 tan theta over 1 minus cos 2 theta isn't 1. Okay, and again, try it in your calculator and you'll see it's not that close to 1 at all. Okay, so it is not a valid result. All right, so small angle approximations are fairly simple. You've just got to remember when you're substituting, whatever the argument is what is then substituted into the small angle approximation. That's where people make their mistakes. Okay, so have a go at I think Mrs. Taylor's doing a worksheet, or if not, I'll post the questions.